Hey y'all, we're going to finish off this unit by talking about circuits in your home and how fuses and circuit breakers come into play. And we'll also look at some complex circuits and look and see if one bulb goes out, what happens to the other bulbs. All right, so in our household, most houses are wired in parallel, which is good because if one light bulb goes out, the whole thing doesn't go out. But the bad part about it is if you plug too many things in, you can cause a problem. You can actually cause a fire if you're not careful. Right? And each connection, when you plug it in, is going to use what it needs and draw the current that it needs. And eventually, more current is going to be used than what the wires can carry, and it can cause overheating and therefore a fire. Circuit breaker in the house or a fuse will allow it'll trip, open, and stop the flow. That's like if you've ever in the kitchen, if you've ever plugged too many things in and you lost power. That's because the circuit breaker tripped to keep it from getting too hot. Okay. So a byproduct of current flowing through wires is heat. Too much current produces heat, and too much heat produces fire. Right. If you have a fuse, the fuse melts. There's actually a wire in a fuse that's designed to melt if too much current goes through, and it breaks the circuit and stops the flow. The negative part of fuses is that you have to replace them. So if you're blowing a lot of fuses, it becomes a bit of a pain. You have to constantly replace them. Circuit breakers are switches that open the circuit and stopping the flow, and they're designed to pop open. And when you're ready to use it again, you just flip it back, and it'll start all over again. Right? And you don't have to replace those very long. You don't have to replace them for a really, really long time. All right, so now we're going to talk about complex circuits, but we're not going to do any calculations here. We're just going to talk about if I have a circuit with different light bulbs in it and I turn one light bulb off, what happens to the others. So here's the first one. Notice that the battery and the first light bulb are in series with one another, but then we have a parallel connection of 2 and 3, and we complete the cycle. So if I am to cut the wire right there, bulb number 1, what happens to these two light bulbs? If we remove bulb number 1, because it's in series with the battery, none of the current will get past this, and so everything goes out. If I replace bulb number 2 and I take bulb number 2 out, then this branch has nothing going through it, but the other branch will. So the first light bulb and the third light bulb will stay on, but number 2 will go out. And then the idea with number 3 is exactly the same. Right? If I disconnect number 3, we still have a path for all the current that travels in 1 and 2. So 1 and 2 will stay on. And which components have the same current? Well, since the battery and bulb number 1 are in series, they're going to have the same current. 2 and 3, since the current splits, don't necessarily have the same current. Then which ones have the same voltage? Well, remember the rules for parallel circuits that the voltages for parallel resistors are equal. So we know that's going to be 2 and 3, even though I mistyped that. That should be number 2 and number 3. All right, now that was a different type of circuit. Now we have a parallel connection. These two bulbs that are in series are parallel to 3, so this is a little bit more complex, right? But if I remove bulb number 1, can anything go through this section? Can anything go through this section? I think yes to this section, no to this section. Right, so I'm going to go. Right, we see that if bulb 1 just gets disconnected, then no more current goes through the bulb 2 either, so 1 and 2 are both disconnected. 3 will stay lit because 3 is a separate path, and the current will travel completely through here back to the battery. If I remove number 2, it's going to be the same thing. Right? Current still can't get through this branch, so 1 and 2 stay out, 3 stays on, and the battery works on 3. And then if I take out 3, then current will go through 1 and 2. The same current that had gone through 3 before now will go down through 1 and 2. All right, a couple other questions that we might see. Which components have the same current? Right, 1 and 2 are in series, so we know 1 and 2 are going to have the same current because 1 and 2 are in series with one another. And which components have the same voltage? Right, that would be the ones that are in series, which would be the battery and light bulb number 2, since they're already parallel to one another. All right, so now if you haven't done your learning/lab check yet, make sure you do that before 11:59 tonight. You have 3 submissions or 3 attempts for it. Make sure at least one of them is done before midnight tonight. And if you have any questions about it, you can ask over the next couple of days and then retake it again before the test if you wish. All right, so y'all have a great day, and I will see you in class.